Imagine being in a world where the sun doesn't shine, where the pressure is extreme, and the temperature is near freezing. Yet, in this harsh environment, life not only exists but thrives. This is the world of hydrothermal vents, a place where superheated water spews forth from the Earth's crust, creating an oasis in the desolate depths of the ocean. The smell of sulfur and metals fills the air, or rather, the water, as giant tube worms cluster around these underwater springs, their feathery plumes waving gently in the current. The sound is almost surreal, a constant rumble, like the distant growl of thunder, as the Earth's internal heat is released into the sea. But what makes this world so fascinating, so captivating, that it draws us in, like moths to a flame? Is it the fact that these vents are home to creatures that can survive in conditions that would be toxic to most other life forms? Or is it the glimpse they provide into the Earth's own history, a window into the processes that have shaped our planet over millions of years? As we delve into the mysteries of hydrothermal vents, we find ourselves on a journey that takes us to the very limits of human understanding, a journey that challenges our perceptions of life and the universe. But before we begin, let's ask ourselves a question: what if the origins of life on Earth are not what we think they are? What if, instead of emerging in some warm, primordial soup, life actually began in the harsh, chemical-rich environment surrounding these underwater springs? The idea seems counterintuitive, yet, as we explore the world of hydrothermal vents, we may find that this paradox is not just plausible but profound. Chapter 1: The discovery of hydrothermal vents begins with a story of exploration, of how these underwater wonders were first discovered, and the impact this had on our understanding of the ocean and its ecosystems. It was the 1970s, and the world was in the midst of a technological revolution. Submarines and deep-sea submersibles were allowing humans to explore the ocean floor in ways previously unimaginable. It was during one of these expeditions, led by scientists like John Corliss and Jack Diamond, that the first hydrothermal vents were discovered. The team was exploring the Galapagos Rift, a region of intense volcanic activity on the ocean floor, when they stumbled upon something extraordinary. Giant tube worms, clams, and other creatures were thriving in areas where the hot, chemical-rich fluids from the Earth's crust were interacting with the cold, oxygen-poor seawater. This was a revelation, a discovery that challenged the conventional wisdom that the deep sea was a barren, lifeless environment. The team's findings sparked a new wave of interest in deep-sea research, as scientists began to realize the importance of these ecosystems, not just for understanding the ocean but for shedding light on the Earth's internal processes. But as fascinating as this discovery was, it only scratched the surface of the mysteries that hydrothermal vents hold. In Chapter 2, The Unique Ecosystems of Hydrothermal Vents, we dive deeper into the biological and chemical processes that make these environments so unique. The vent ecosystems are supported by chemosynthetic bacteria, microorganisms that can convert chemical energy into biological energy. This process, known as chemosynthesis, is analogous to photosynthesis but uses chemicals instead of sunlight as the primary energy source. These bacteria form the base of the food web, supporting a diverse array of species that have adapted to live in these extreme conditions. From the giant tube worms, which have no mouth or digestive system and rely on the bacteria living inside their tissues for nutrition, to the vent crabs and fish that have evolved unique physiological adaptations to survive in this environment, each species plays a crucial role in the ecosystem. But hydrothermal vents are not just biological curiosities, they also offer insights into the Earth's geological history. In Chapter 3, Windows into the Earth's Past, we explore how these vents can serve as natural laboratories for studying the Earth's internal processes. The fluids emitted by hydrothermal vents carry with them traces of the Earth's mantle and crust, providing scientists with valuable information about the planet's composition and the processes that shape it. By analyzing the chemicals and minerals present in these fluids, researchers can gain insights into the Earth's thermal evolution, the movement of tectonic plates, and even the potential for mineral resources. This chapter takes us on a journey through the Earth's history, from the formation of the oceans to the present day, highlighting the role that hydrothermal activity has played in shaping our planet. As we navigate through the complexities of hydrothermal vents, we begin to realize that these ecosystems are not just fascinating in their own right but also hold clues to some of the most profound questions about life and the universe. In Chapter 4, The Origins of Life, we delve into one of the most intriguing aspects of hydrothermal vents, their potential role in the origins of life on Earth. The idea that life could have begun in the chemical-rich environment surrounding hydrothermal vents is both captivating and challenging. It suggests that life may not have required the warm, sunny conditions often imagined but could have thrived in the harsh, high-pressure environments of the deep sea. This hypothesis is supported by several lines of evidence, including the presence of complex organic molecules in vent fluids and the ability of certain microorganisms to survive and even thrive in conditions similar to those found near hydrothermal vents. The implications are profound, suggesting that life may be more resilient and adaptable than we previously thought, and that the origins of life on Earth may be more closely tied to the planet's internal heat and chemical processes than to surface conditions. As we conclude our journey into the world of hydrothermal vents, we are left with more questions than answers. What other secrets do these underwater springs hold? How can studying these ecosystems help us better understand the Earth and the potential for life elsewhere in the universe? The allure of hydrothermal vents is not just about the mysteries they hold but about the journey of discovery itself, a journey that challenges our perceptions, expands our understanding, and inspires us to continue exploring the unknown. And so, we return to the question we asked at the beginning: what if the origins of life on Earth are not what we think they are? The answer, much like the vents themselves, lies in the depths, waiting to be uncovered. The journey to uncover it is what makes the exploration of hydrothermal vents so captivating, a true adventure of the mind and spirit, into the unknown, and into the very heart of our planet.